Hello, everyone. My name is Lars Moltu. I'm sitting here in Oslo, Norway, in the freezing cold. Fortunately, indoors. A little bit about myself. I've been navigating the intricate world of business development, project management, and been doing all kind of architectural work for over the two past decades or so. But today, I'm excited to share with you a fascinating project that merges my core interests with a dynamic and equally exciting field of machine learning and artificial intelligence. And I've chosen for this case study to explore how artificial intelligence can help improve and also enhance the onboarding process for new hires in typically competence-driven businesses. So I'm thinking businesses like consulting and tech firms. And it's also about making the first steps for newcomers, not just informative, but also cost-efficient and tailored to the skills and previous experiences for each individual new hire. So let's buckle up and dive into this adventure. Before we dive deep into our project, it's crucial to frame our discussion around three key questions. These questions are essential in evaluating the opportunity of AI in improving or enhancing any business process. And they will also guide our exploration today. First, is there a problem? Well, if there isn't a problem, why do anything about it? But it's really about identifying the actual challenge or inefficiency in the current process. And if that is the case, then you can move on to the second question, which is, can artificial intelligence or machine learning help solve it? This question requires assessing the feasibility and impact of applying AI and ML solutions. And third, and equally important, does anyone really care? And it's about understanding the significance and value of solving this problem and communicating these findings with relevant stakeholders, which you might find to be the champions you later need to get the project off the ground. And as we progress through this course, or case study rather, I will try to tackle each of these questions one by one. Okay, addressing our first question, is there a problem with the current onboarding process? Now, the onboarding often spans several weeks, costing companies an average of $4,000 and even more, according to a study, and that it doesn't even take into account people that they engaged with during the onboarding process to learn new stuff. So time and cost is obviously an issue. Related to onboarding pathways, we can not only streamline them, we can personalize onboarding to match individual roles, whether they're operational or client-facing. And this will ensure faster integration and role-specific readiness. And last, I want to address that this could also be a foundation for a modular innovation going forward. So let's just imagine a system that evolves over time and it integrating predictive capabilities to forecast market trends and then evaluate the suitability of applicants. That's not just about efficiency. That's about something bigger, like strategic foresight, anticipating the time and resources needed for optimal onboarding. So at least I think the main problems of most current processes are time and cost related, lacking in personalized onboarding pathways, and also you might want to add that it sort of also implies a lack of, let's call it, a holistic, innovative vision. So I'm indeed confident that the problem does exist, and there's plenty of opportunities for improvements. So let's just cross that one off immediately. And there we did. Okay, as we address our second question here, can artificial intelligence, machine learning help solve this? I think it's important to acknowledge that many companies already have differentiated onboarding tracks. A new sales executive journey would differ significantly from that of let's say, a cloud solution architect. But I guess that this is where artificial intelligence and machine learning can take things to a completely new level. In organizations, particularly those experiencing rapid growth or high turnover, the diversity and volume of new hires can be absolutely challenging to manage efficiently. And I think it's especially true for larger companies or those with ambitious growth plans, where the scale of onboarding is really extensive. And artificial intelligence, I think, can sort of intelligently analyze and automate aspects of this process. For example, by using machine learning algorithms, we can predict the specific needs of each role and tailor the onboarding experience according to that. So this isn't just about assigning predefined tracks, it's about continuous learning and adapting to the evolving skill sets and roles within the organization. So in essence, artificial intelligence doesn't just replicate existing manual or heuristic models. It evolves them, making the onboarding process not just reactive, but proactive, adaptive as well, and far more efficient. So I think we can say yes to this one too. Okay, as we turn into the final question, does anyone care? Let's be clear about one thing. The stakeholder interest in this sort of, or any sort of AM or ML driven onboarding initiative is not just going to be significant, it's going to be essential. So the business case sort of hinges on the tangible benefits of improved efficiency, better role fits, and faster integration of new hires. The approach I would propose would, for most, if not all, the projects involving artificial intelligence is an agile approach, as they are inherently experimental in nature. This means deploying small, autonomous, and focused teams, typically comprising of subject matter experts, data scientists or engineers, developers, and a team leader. And they will be operating in sort of rapid sprint cycles, somewhere in between sort of 1 to 4 weeks. And please note in this setting that one person can have several roles, so the team size could be from technically 1 or 2 up to 6 or 7, but I wouldn't go above that. So, but each sprint should culminate in a tangible delivery, and that should be assessed and refined based on stakeholder feedback. But let's go back to my first point. Buy-in from the right people is crucial. We need stakeholders who understand the uncertainties and all the risks involved and are committed to the whole journey. And I think also starting small is key. By initially sort of focusing on basic high impact areas, we can develop a proof of concept that demonstrates the value of our approach. And from there, I think we can incrementally build, expand, and sophisticate our solutions. But in summary, the question was, do someone or people care? And it's a difficult one to answer. I think the hardest one in this case. The success of this initiative would depend on stakeholders' commitment and risk appetite. And it would require a sound business case and obviously also a highly qualified and respected delivery team. But I've decided on yes for this case study. But be aware, this might be the most important question of them all. Well, welcome to the next phase of our journey, where we will delve into the framework guiding our data mining or analytics process within the AI project itself. I will utilize the CRISP DM process. It starts with understanding the business and moves through data understanding and preparation and culminates into modeling, evaluation, and deployment. However, as a certified Google data analyst professional, I often align with Google's streamlined approach, which is based around ask, prepare, process, analyze, share, and act. I believe both will fit the purpose of having a structured approach that guides you and helps you along the way. I would normally lean towards what I'm most familiar with, and that's kind of natural, I think, for everyone, or whatever the company I would work for have implemented as their own data analytics framework. So both methodologies mentioned, while distinct in their steps, share a common goal, and that is to extract meaningful insights from data and leverage these insights for informed decision making. And I think each step, whether it's in CRISP DM or Google's process, is a building block in our journey to optimize business processes using data and AI technology. In our journey, which is to revolutionize onboarding in competence-driven companies, such as consulting and tech firms, we begin with a clear understanding of the business context. And the first step is basically defining the problem. Our target users here are new hires. And we've identified a critical issue, which is the problem statement. And in this case, that's the existing onboarding process that sort of focused around a one-size-fits-all approach, and that leads to inefficiencies. And this matters because a quick and effective integration of new hires is crucial for productivity. Currently, companies rely on standardized programs which lack personalization and adaptability too. And then we move on to sort of defining success. And what we want to do here is we want to create a faster and more effective onboarding experience. Our challenge lies in the availability of quality data and ensuring user engagement. And success, it will be measured through metrics like time to competency and employee satisfaction with the onboarding process. Targets that are to reduce onboarding time and increase satisfaction scores. And finally, we have to sort of look at identifying relevant factors that might play into this. And obviously, to navigate this landscape, we will need to bring in subject matter expertise in HR processes and development of AI solutions. And also factors such as the diversity of employee roles, the company's growth rate, and turnover rates are also crucial considerations to take into account. But in essence, I think we can say that our goal is to transform onboarding into a process that is as dynamic and diverse as the companies and individuals it serves. Moving into the data understanding phase of our project, we focus on 3 core activities: gathering, validating, and exploring data, each vital for building a robust AI model for onboarding. First, gathering data. It's all about collecting the right information. We dive into HR records for insights on employee demographics and roles. We tap into performance systems to understand skills development and use feedback systems for gauging satisfaction. Our aim is to label and categorize this data, creating sort of distinct features that mirror the real world and the real world diversity of employee roles and onboarding experiences. Next, validating the data. This step is about ensuring our data's integrity. It's not just about having the data, it's also about having the data we can trust. So we rigorously check for accuracy, completeness, and address any issues like missing data or outliers. This ensures our AI model is built on the foundation of quality data. Finally, exploring the data. And here we dive deep. Through statistical analysis, we uncover trends and distributions. We also focus on simplifying our data structure, which helps us in highlighting the most impactful variables. It's in this exploration that patterns begin to emerge, revealing how different factors influence onboarding success. And each of these steps is a crucial piece of the puzzle, giving us a clearer picture on how we can use AI to revolutionize the onboarding process in competence-driven businesses. Okay, as we progress into the data preparation phase, our focus sort of shifts to three new key tasks. That's splitting the data, determining the feature set, and preparing for modeling. And I really want to keep this one short and sweet, so let's get going. When we talk about splitting the data set, our first step is to divide our data set into training and testing sets. And that's an important task, and it's often led by data engineers, even though, depending on the complexity, even I can do some of that. It is done because it ensures that our model is trained on one set of data and validated on another. And this separation is done to avoid overfitting or to make sure the model can effectively respond to new unseen data. And the second part is determining the feature set. This is where feature engineering and selection come into play. Data scientists and domain experts collaborate to transform and refine the data, extracting meaningful features that accurately represent the complexities of the onboarding process itself. So the main purpose is to identify and select those features that have the most significant impact on the effectiveness of onboarding, ensuring our model is focused and efficient. And the final step is preparing for modeling. And in this final step, we encode categorical features like roles and departments into machine-readable format. So data transformation is really the key word here. It's also where we scale and standardize the data for consistency, a task often overseen by data analysts too. Additionally, we address what we call class imbalances, and that's a very, very crucial step. And it's to make sure that our model's predictions are fair and unbiased. And that's a huge topic in itself, so I won't delve into that here. But it typically involves close cooperation between data scientists and HR professionals to understand the nuances of different roles and their representations in the data. And through these sort of meticulous steps of data preparation, we can have at least some confidence that we have established a strong foundation for building an AI model that can be a starting point of actually working with models that eventually will transform the onboarding experience. In the modeling phase of our project, we have two main areas of concern, and one is model selection, the second is model tuning. And each is crucial for developing an effective AI solution for any process applying machine learning or AI technology. So let's look at them one by one, with the model selection first. At this stage, our sort of primary task and objective is to evaluate various models and the algorithms within them through so-called cross-validation. And this is a rigorous process, and it helps us determine which model performs best with our specific onboarding data. And also in production environments, we might want to do cross-validation, and this happens basically through something we call shadow models. So we have one main model that is running the process, and then we might have a few sort of objectives or sub-processes that go through another model. And then if that other model performs better, we might want to choose that one to become the main model. And this can also be done automatically, sort of depending on the setup. But it's typically a sort of a collaborative effort, at least in the early stages, involving data scientists and machine learning engineers to ensure we choose the most suitable algorithm. Equally important in this phase is documentation and versioning. Keeping a detailed record of our selection process not only aids in transparency, but also helps in future developments and possibly handovers. So that doesn't really differ much from regular versioning we know from the importance of from other software development projects. And the next is model tuning. Once we sort of selected our model, we have to fine-tune it. And this involves optimizing the model's hyperparameters to ensure peak performance. And we also here document each step of this tuning process, maintaining version control and to track the evolution of our model. And the final part of this phase is planning for model retraining. As the nature of onboarding and employee roles changes, our model needs to adapt to that and ensure that it remains relevant and effective. And we typically see two things here. We can see that models sort of fail pretty much immediately because of might not be fit for purpose or whatever reason, not well enough done work in earlier phases. But what we can be quite certain about is that over time any model will degrade, and this is due to concepts like data and concept drift. An example of concept drift is COVID-19. That made a massive impact on a lot of models out there. You can think, for instance, within fraud detection. One of the parameters they look at there often is one-way flight tickets. But during COVID-19, people weren't trying to run away with the money. They were trying to get home because they knew they weren't going to be locked down. So that set off quite a few alarms, I would presume, that weren't really valid. So, but through these steps in the model phase, what we're really trying to do is craft an AI solution that's not just powerful, but precisely aligned with the unique demands of the onboarding process we're trying to improve. Okay, in the evaluation phase of our project, we thoroughly test our AI solution to ensure it meets the quality standards required for enhancing onboarding processes. And this phase is akin to any comprehensive software testing. We don't only want to ensure our services is technically sound, but also effectively serves its purpose. Let's talk a little bit about evaluating results. First, we score our model using test data sets. This is where we see how well our model is predicting onboarding success. which is crucial for our objective and success criteria. Then we try to make sense of these outputs, drawing insights into the model's performance. And it's not just about numbers, it's about understanding what these numbers mean for new hires and their integration into the company. Remember, that's our target group. Next, sort of testing the solution. And this step encompasses a variety of tests, software unit and integration tests, much like those found in ISUKB, and it's applicable, I think, and similar to any software testing regime. Here you may want to get a test manager on board, but even a better idea might be having someone with a solid understanding and experience of testing in the team from the get-go. We want to ensure that the technical robustness of our solution is in place, and we want to perform specific model tests, including unit tests and checks for alignment with our initial expectations. And finally, user tests. And these are perhaps the most telling. We put our solution to the test in real onboarding scenarios. And the proof of the pudding lies in the effectiveness and user reception. Well, welcome to the deployment phase. That's sort of the grand finale of our journey, and where we set out to revolutionize onboarding with artificial intelligence. So this is where our plans and hard work come to life. A moment both thrilling, critical, and I can tell you, it can be nerve-wracking as well. So let's first dive into sort of deploying our solution. Here we're not just launching any simple tool or anything like that. We're integrating a new heartbeat into the very core of the onboarding process. And the deployment process needs to be clearly planned, as this will be the cutover from the past and into the new. A lot of things needs to be taken care of, such as making sure APIs are set up and firewalls are open, and we need to make sure that we can scale our infrastructure from going from test to prod, and also making sure it will meet growing demands, ensuring our system is not just effective at launch or today, but also future-proof. And let's not forget the cornerstone either of any digital solution, and I presume you guessed it, and that's security. Safeguarding data and ensuring compliance is always paramount. This phase is all about sort of meticulous planning and execution, and setting the stage for a successful launch. Also, let's talk a little bit more about monitoring and adaptation. The deployment day is really just the beginning. As we monitor our solution, and I mean every piece of data, every process, and every output should be under constant scrutiny. It's like watching over a complex living ecosystem, ensuring it thrives and adopts. So retraining shouldn't really just be a periodic task. It's an ongoing commitment, as shifts in data and concepts can happen rapidly, as with COVID-19. Whether scheduled or triggered by shifts in sort of data trends or related to concepts such as market demand, we ensure our model remains reliable, affecting and guiding the onboarding journey for new hires. And as we step into this phase, it's a blend of anticipation and determination. The excitement of seeing our solution come to life should be sort of a magical moment in your life, but it needs to be coupled with resolve to ensure it sort of performs flawlessly. And this is where our hard work will pay off, where we can see the real impact of our innovation. So here's to a successful deployment and the transformative powers of IE, bringing it into onboarding processes. Well, first I would like to thank anyone who has set the time aside to follow me all the way here. We are close to the end, but there are a couple of more things to address before we can call it a day, or I can call it a day. We've introduced sort of a transformative solution concept for onboarding in specialized and knowledge-intensive sectors like consulting and tech. But it could be broader than that as well, of course. And our goal was simple yet ambitious, to revolutionize how new hires are integrated into their roles. And how? By leveraging the power of artificial intelligence and machine learning to tailor the onboarding experience. And I will not spend more time on the solution concept as it has been repeatedly stated before. So let's talk about bringing this idea to life through a series of iterative experiments and validations. Sort of a structured approach to ensure our solution is just not innovative, but also practical and effective. So that's in the earlier parts, let's break it up into phases. So in phase one, basically, it's initial testing. Well, we've sort of decided to start small, implementing our model in a control environment. This might mean focusing on particular departments or role types, or it's like dipping your toes into water, testing the temperature before you really take a huge dive in. And phase two is about the feedback loop. Here we're really starting to learn. We'll gather insights from new hires who's experienced AI-driven onboarding, as well as from HR managers overseeing the process. This feedback is crucial. It's the compass guiding our next steps, showing us how well our model meets the diverse needs of new employees. So this is basically sort of the end of the proof of concept phase, I would say. And then we get into another phase, which is refinement. And armed with all this feedback, we have something to work on and refine. Think of this as the sort of the sculpting stage, where we can chisel away the rough edges of our model and enhancing also along the way its predictive accuracy and adaptability. It's a process of sort of continuous improvement, always aiming for a better fit. And in phase four, the expansion phase, with a sort of refined model, we're ready to broaden our scope. We'll gradually introduce the model to more roles, more departments, keeping a close eye on its performance across a sort of a wider spectrum of the workforce. And in the sort of final phase, or the final evaluation, if you might say, this is where we measure our success. Does our solution truly shorten onboarding times? Has it improved employee satisfaction? So these are the metrics that matter, the indicators of our solution's actual impact. So I think in summary, through these sort of iterative steps, we're not just testing a concept, we're sculpturing a solution that is as dynamic and diverse as the workforce it's designed to support. So it's a journey of discovery, refinement, and ultimately transformation. Okay. User requirements and constraints drive system design, and system design drives selections of technologies, as shown in the figure below. As someone who's been working pretty close to 30 years now in the IT business, meaning information technology business, I sometimes sort of wonder if the I is almost forgotten and it's almost all about technology. It should be vice versa. in my humble opinion. Okay, but that aside, looking at our objective to improve and enhance onboarding process, we come across basically three crucial system design decisions. And the first is cloud versus edge. Second, offline versus online learning. And third, batch versus online predictions. So let's quickly dive into what these mean and how they can apply to our project. So the first one is cloud versus edge. Cloud computing relies on remote servers for processing power. And that sort of offers great flexibility and scalability. So we can think about services like Amazon Web Services or Google Cloud. Edge computing, on the other hand, processes data locally, closer to where it's generated, and is crucial for tasks like needs ultra-low latency, such as self-driving cars. For our onboarding solution, we'll lean towards cloud-based approach. I think I'll tick it off already. And why is that? It offers the computer power and scalability we need, especially as we handle diverse data sets and complex machine learning models. While Edge has its merits, our solution doesn't really require the ultra-low latency that Edge is best for. And I presume we'll be online, so that's not really a concern either. So then we talk about offline versus online learning. Offline learning means training our model with existing data, refining it before it goes live. Online learning, in contrast, continuously updates the model with new data in real time. You can think about how social media platforms constantly evolve around and with user interactions. For the initial stages, we'll start with offline learning. It gives us control and stability as we fine-tune our model with well-curated data. So we'll click that one off too. But as our system matures, we might, somewhere along the line, shift towards a hybrid model, which includes online learning, for instance, to quickly predict changing market demands for our services and adjust to that faster than the competition. But I really can't see that happening in the near future. Third, we have batch versus online predictions. Batch predictions process data in groups at scheduled times, while online predictions happen instantly in response to data input. Real time isn't a necessary thing to have in our scenario. We're not in a sort of a high stakes environment like stock trading where maybe milliseconds matter. Therefore, batch predictions are our go-to method. And I think also they align well with the periodic nature of onboarding processes, providing sort of ample processing power without the need for instant responses. So in summary, our design choices are cloud-based solutions, offline learning, and batch predictions. As for the more detailed technical decisions, they're beyond our current scope and something we might explore as the project evolves. I may also remind you of my initial rant on the balance between information and technology focus in IT. So that comes a little bit later. Okay, as we now approach the culmination of our onboarding enhancement project case, we will end with addressing potential risks that might surface in production. Sort of anticipating these challenges is, I think, a key to ensuring the resilience and effectiveness of such a solution over time. I've decided to evaluate the various risks and give a risk score from a scale from 1 to 10. That's sort of a combined score of chance of occurrence and impact. I could use a risk quadrant for this, but I believe this works equally well for this purpose here today. But I've noted sort of 4 risk areas, and the first one is training and serving skew, and This occurs when the model performs well during training but poorly in real-world applications. It's like preparing for a marathon on a treadmill but struggling in an actual race. For our project, this could happen if the onboarding scenarios we train on doesn't actually reflect real-world conditions new hires face. So regular updates and real-time feedback loops can mitigate this risk. But I rate this as the highest risk of all, with a 9 out of 10. And second one is latency issues. Speed is always essential, but not our top priority at all, given the nature of onboarding. However, any significant delays in processing could hinder the user experience. So we'll have to sort of monitor system performance to ensure efficient data handling. Yeah, maybe especially during sort of peak hiring periods. Gets a 2 out of 10 from me. It's not a big issue, but can have an impact if our model gets overloaded or stop working. And thirdly, it's data drift. So over time, the types of roles and skills required in the industry will evolve. This change in underlying data can reduce the model's accuracy. So we must stay vigilant and continuously updating our model to align with the current industry trends and requirements. I rate this as 5 out of 10, as our model should be able to adjust to that types and changes in roles. And even with the sort of ongoing technological disruption, the roles will not change that much, I think. And fourth and last, and this is where the very sort of definition of a successful onboarding experience might change. As workplaces, cultures, and technologies evolve, what constitutes effective onboarding today might be outdated tomorrow. So we'll need a flexible model that adapts to these evolving concepts. And I believe this is sort of more important, at least in the short term, than data drift. AI will change the workplace, and some will lose out and others will be winners. In our case, I believe data and concept drifts are closely aligned or connected, but the concept of disruptive changes due to AI is stronger than the data input, I would think. So in addressing these potential risks, we're not just preparing for what might go wrong, we're also ensuring that our solution remains relevant and robust and reliable. So it's about being proactive and not just reactive. But this marks the end of our journey through a lot of slides. And I certainly hope that you've enjoyed it, being here with me today. And I even more so hope that both you and myself get the opportunity to bring such solutions to life somewhere down the road. Thank you very much.